Okay, good morning, everyone. Welcome to our partner webinar for ST5680 DC Hipot Tester. My name is Daniel Ruben, Regional Sales Manager for Southwest Europe, and I'm with my colleague.
Yes, my name is Roy Hali. I am the head of the product management department at Hioki Europe. And my role in this webinar today will be to be in charge of the Q&A sessions. So if you have any questions during the webinar, please use the Q&A box at the bottom of the page and put your question there. And at the end, there will be a Q&A session where we answer the questions that you might have. Please.
Exactly. So it will take roughly 30 minutes. We have muted all participants, and as Roy said, please enter all questions into the Q&A function already from now on. We will have a recording which we will share with you after this presentation, but please remember only to keep that for your internal use because we have some competitive material inside this presentation. So today we want to discuss with you the latest new development of Hioki. It's a DC Hipot Tester, DC specifying for the battery industry. And in this webinar, we will give you a brief understanding about Hipot testers, safety testers, what they are doing. We will show you some applications and features of this device based on these applications. And then at the end, we will compare it to the market competition at the moment. Out of this webinar, we hope that you will understand three main features this time. The DC Hipot Tester is having three main USPs, which makes it an all-inclusive Hipot Tester, especially for the battery industry. So having a higher current resolution, especially compared to our existing range, is a key feature, but also to understand about any arc discharges of the battery packs, and also to have trend data which are being stored and can be used for traceability purposes. These are main features we should focus on when we talk to the customers. Additional features like a breakdown voltage test function or contact check function, we will also show you here briefly. How the webinar is being structured, as I said, first the withstanding test, what is it doing? And we want to compare that again to the insulation test so that we have a clear differentiation here. The applications to understand first which customers to target, then the key features based on challenges in the industry and how we want to solve these challenges. Then we have the cross-reference at the end, and of course the marketing assets for you to promote the product successfully will also be part of the presentation. At the end, all questions you have, we will answer in this time. So then first, let's look at what an insulation, what a Hipot tester is doing compared to an insulation resistance tester, and then we will see which product to use at which level. So first of all, dielectric withstand test, Hipot test, safety test. These are the words for having basically a final test already on an assembled pack or module. Here, this product is completely focusing on the battery industry. That's why we also have here just the application of a battery module. And it is the necessity of a producer or even an R&D stage to ensure that, first of all, the battery has a higher integrity in terms of withstand, but also that you do not have any issues about insulation or a possible breakdown at the end when the product is ready for the market. While the insulation resistance test, that's happening on a different stage. So this is happening on cell level. You typically have the insulation resistance test being done before and after the electrolyte filling to understand whether you have any problems in the insulation to avoid any degradation, self-discharge, and so on. The test voltage is typically much lower. So around 200 volt is something what we see from our customer base when they do the test voltage here to see if the insulation is failing or not. While here we might have several thousands of volts being applied, and the main differentiation of these products not only is the DOT, so cell versus module, but the circuitry, how the test is being done, and what kind of parameter the customer is interested in. So as you can see here, we have ST5680 as a DC only withstand test and insulation resistance test, while 3153 is an altogether version, AC and DC, and 3174 is AC only. The circuitry is quite easy. We apply a DC or AC voltage to the DOT. Out of that, we will sense the current, and the customer here is mainly interested in understanding about leakage current to understand whether the insulation is already bad here when the assembling process was being done, to avoid any problems in the worst case also that there is any electrical shock happening because of the leakage currents. Now we compare against an insulation resistance tester. In this case for battery, it would be the BT5525. Here we will apply a very stable DC voltage to the DOT because we know the very stable DC voltage, and we have a very, very high resoluted sensing of the current. We are then able to calculate the resistance value. So here it's about the insulation resistance, which is interesting for that. One point for the portfolio, ST5680 is an addition to our existing portfolio, specifically targeting the battery industry. These kind of safety tests are also being done when we do a repair, for instance. But typically these would be on general purpose devices, and here AC withstanding test is a typical method to be done. So therefore 3153 and 3174 will be still existing in the product portfolio, also coming at different price levels, but this is something we can have a look at later. In regards to application selection guide, when to choose which device, again, as a reference, the insulation resistance test is being done on cell level. The insulation resistance is the main feature. It's happening at a different level of voltage, so 500 volt for the BT5525 and 1 kilovolt for the ST5520, and the resistance value is the main interesting point. While when we look at Supermag ohmmeter, also resistance value is very important, but on a higher resolution or higher display range, because we are testing components, and these components have a different resistance value to be measured, and also we can apply a much higher voltage here. The Hipot tester is, in this case, an insulation resistance test capability plus withstand voltage test. We still urge you to not use this Hipot tester for insulation resistance test from the beginning if you do cell testing, because the sensing is a different one, and also it doesn't have like a breakdown detection function for partial discharges in this device. So therefore, the insulation resistance test is an addition. It can do it, but on a cell level, we would go with the BT5525. Where we would suggest using ST5680 is to have the withstand test for the safety test, for the type test to understand at which level the battery pack or module would break down, or at the end of the line to do the test. So here you have the cell test before and after electrolyte filling, and here you could do already the safety test with ST5680. Let's look a little bit closer at the main applications, which customers you can target with ST5680. So to start with, it's a little bit more R&D and classification of the produced or assembled pack and module. It's a breakdown voltage test. And this breakdown voltage test is a typical type test. There are IEC standards in the market which define how this test has to be done. So what you can see here, you have either a linear approach of increasing the test voltage, or you have steps, so ramping up in terms of steps. And at the level of voltage when the device is breaking down, that is the so-called breakdown voltage point, to understand where you will have a weak spot of your pack or the module. So this is the screen of ST5680, what we have seen here in this GIF. You then also can see on the screen of the device. So compared to 3153 or 3174, it's now possible to have a graphical display showing exactly the test and the test voltage being applied, and also how the current is reacting, not only in this graphical form as a waveform, but also here in numerical values. Another application is end-of-line test. So once you have the batteries being assembled to a pack or to a module, you want to ensure that there is full electrical insulation happening and that there is no problem in your assembling process. It is especially interesting to have this assembling process also recorded or for creating reports, because if you have any problems with your installation, that can lead to severe issues for safety, because in a very bad case, it can also happen that you that this pack or module is catching fire, and therefore such an end-of-line test for after the assembling is basically mandatory. A third application is to test and to do the type approval for solar panels. So what you can see here, typically a solar panel nowadays is 1500 volts, and also in the solar industry there are IEC standards, and these standards specify that such an Hipot test needs to be done at 4 times higher than the system voltage plus 2000 volt. With ST5680, we have the first device in the market being capable to have 4 times 1500 plus 2000, so up to 8 kilovolt test frequency. So so this is then a unique point for the device to promote in the solar industry, where you have producers of photovoltaic systems, in order to finalize the R&D stage and guarantee that there is no issue with the insulation of the products, and the type class test is being passed. So when we look at the key features and solutions, we want to make it easier in terms of understanding by mentioning what are the main challenges and how the engineers in Japan have designed ST5680 to respond to these challenges in the market. So one of the biggest challenges is that the resistance of the insulation is continuously increasing, and that makes it even more difficult to have a proper judgment of the battery packs and modules. So here is a generic Hipot tester. You simply see it has a pass and it has 0.00 milliamps. The problem is that with 0.00 milliamps, due to the higher resistance values more and more, it is very hard to determine whether there is any insulation breakdown possible to happen in the near future. In order to understand about the higher insulation resistance, the necessity is to have smaller current values to be monitored and to be displayed. And that is why our engineers came up with a device which has a much higher resolution, and this is 1 nanoamps, 0.001 microamps. So this gives a much better and more sensitive possibility to not only have a pass-fail based on the 2 digits after 0, but 3 digits to identify if you have any problems with leakage current. So what you also can make use of with this higher resoluted current value, it gives you also a possibility again for the grading. So if we make now a reference to BT5525, with the BT5525 based on the BDDs, the partial discharges happening inside the cell, it gives you another parameter to grade the battery cell. And if you now look at the smaller leakage current values here, this is another way to interpret the cell much better. And this gives you also a possibility to see whether or in case of an increasing leakage current over the time, to do some or to take some actions in the process before, so that this kind of leakage current will be back to the normal level where it's supposed to be. Another challenge is to have arcs happening inside the battery pack, but only seeing arc shown on such a generic device. So what to do if you have only this kind of information? You will simply throw away the battery pack, could be a case, or you simply say, I have only seen one arc. Okay, let's keep it. The problem is that this kind of level of information is then not giving you enough room for interpretation, and therefore what design is best to also have a discharge waveform display. So this discharge waveform display will not only show you the arc in terms of a transient here, but it also gives you the post measurement of the parameters later on with very high resolution. And how to do that? Well, ST5680 is not only a Hipot tester per se, but it features also oscilloscope functions. So the capability of having 500 kilosamples per second, recording the data for a longer time in a very fast way, gives then the customer the possibility to display the transients and the leakage, the transients, what happened when you inject the voltage, and also the current which happens in here, to determine whether the installation is degraded or not. So it can be the case that an arc is happening and the leakage current goes back to a smaller level, meaning there is no issue with the insulation inside, and therefore no reason for assuming there is any potential degradation happening. That means the ST5680, not only a safety tester, but also with the oscilloscope function, gives the customer a much better way to analyze and to create the battery packs and modules during the production process. And afterwards, when they do the end of line test and an arc is happening inside. The third and especially most expensive, I would say, challenge is traceability. You have seen in the news also once in a while cars catching fire. There are issues with battery packs and modules in the market when they are being transported. Logistics companies are also a little bit afraid of that. Everything around battery can be a danger, and therefore having traceability data gives the producer or assembler the backup of having a report saying, hey, I did all the tests according to the specification, because if you haven't done so, if you haven't done the tests properly, and if you cannot prove that, at the end you will have you might even face legal consequences. You might need to pay a lot of money for that. And therefore, these kind of accidents can become very costly. Our solution is to have these data of the test being recorded, even in a form of a trend graph. So this makes it then again possible for the customer to have a very good level of interpretation. So as you can see, we are able to measure leakage current and insulation resistance at 100 milliseconds interval. Here having that kind of a waveform, and that makes it much better to determine whether anything has happened during the testing process. And if everything has happened in a good way, you have a pass and you have a level of current leakage which is completely satisfying. In a case of an accident, you can always prove I have done the test according to the specifications and everything was being fine. Another point is that if you have any issues here, you can see, then you can already go a step back and see if anything in your production or sampling process is leading to an increase in leakage current, and therefore you can reduce any errors or any problems inside your production plant. Coming to another challenge, which is especially interesting for system integrators, production sites, when everything is being automated. It's when you have a wrong and incorrect measurement of the device under test. Our solution is coming from the ATE department. So where we have, for instance, the flying probe testers, those guys are already using a 2-wire contact check function. So here for our product portfolio, we could make use in the BT5525 for the battery installation resistance tester, but also here for the Hipot tester to look at capacitance values. So we have a min maximum value in which we can set a threshold, and if the threshold is being exceeded or underachieved, it will give back feedback from the device to the PLC that something has gone wrong in terms of contact error. So you might need to do the testing again because the points were not being probed correctly, or it can be a hint that the test leads are broken or that your tips are being worn off. So even looking at the capacitance values and you see a drift over time will give you an idea that, for instance, the tips are wearing off slowly, and therefore in the near future, replacement of the tips is recommended. Another important point why a 2-wire contact check function is superior to the 4-wire method. It's not only that you can save 2 wires, but also looking at the points to probe on, they are becoming smaller and smaller. And if you have then only 2 probing points to set on this installation point here, or sorry, enclosure, or on the pole, it's easier than with 2 points only and not with 4 points. As a last part in this presentation, we want to show you the main competition in this market. So where we see most competition from is Kikusui, GW Instech, or Chroma. And what our ST5680 wants to bring to the market specifically for the battery industry is an all-in-one device at a very attractive price with very detailed features made for the battery industry. So what you can see here, besides the GW Instech, it's the only device having this, for instance, waveform display. Doesn't might not be too interesting in a display form for system integrators, but the display is, of course, not the only way to see these data, but all these data can be stored and shown also on through the PLC, through a PC, on the software screen, and therefore these data are very, very important. And also when you now compare, you have here all 4 main features included, and GW Insync as well. We will always have the problem of the resolution. So this resolution is a very, very important point. So we see rather Kikusui as a competition because of this kind of resolution, but what Kikusui cannot do is, for instance, the waveform displays, but also the breakdown voltage test. And this is especially for the class type tests, very, very important. So what you have as a requirement for designing the battery pack or module, you also want to have later on with the safety test and offline test. So here with ST5680, you have a all-in-one device, and also the contact check function, very, very important feature for the automation industry. On the last slide for the main presentation part, here is a summary which should be helpful for you to easily remember why those 3 main features and the additional functions are of interest for customers. So the leakage current, as I said, due to the higher insulation resistance value, it's just important that you have better resolution. The very fast sampling and high level of detail with this oscilloscope function, on those 3 parameters, voltage, current, resistance, gives much more room for interpretation, and the trend data for avoiding liability claims. This is something where automotive industry specifically will be quite happy with. The additional functions, making it an all-in-one device, the contact check function and the breakdown voltage test. Therefore, it's a device at a very attractive price with many features included. So that you can also make this available to your customers. We have several marketing materials listed on this page here. So first of all, the main landing page of this product, a link to the application notes, all relevant information for this product to be put onto your website so that you can bring this product live, including the pricing information for your internal users. But of course, any other marketing assets so that you can promote this product are to be downloaded from here. Also, please make use of these assets because there will be another public webinar, this time for ST5680. So far, we have to save the date, but you will have the material to promote the public webinar very soon. A big thank you as well for the last public webinar, the way how you have pushed it. For your reference, here is the result of the attendees. As you can see, we had 93 attendees for BT5525. Considering that this product is meant for cell manufacturers, so smaller market within Europe. It's a very nice number, and the ST5680 targeting on everyone assembling, so many more customers available in the market. There is definitely a very good potential, so please keep that high momentum you had for pushing BT5525, also for the ST5680, so that we can have another successful public webinar and some more success for your customer base. Now we are at the last part, the question and answering. Any questions so far?
Yes, we have already 3 questions in the Q&A box. If you still have questions, please put them in so that we can address them. The first question is related to ARC, the ARC measurement that we have shown in the presentation. And the question from Arne is, ARC, what does it stand for? Well, ARC is not basically an abbreviation for a term, but ARC is really just the discharge. So if you go and see lightning outside, then you see also an arc when there is the discharge. So it's really kind of a flame during the discharge when an arc is happening in a battery cell. So it's a physical thing in this case, the arc. Then the second question also from Arne, the safe test results, where? Inside the unit, USB stick, software. Normally this kind of instrument will be integrated in an automated test line for battery packs and battery modules. And then after the measurement has been done, the PLC or the control system will immediately take out the measured data and save it on a data server. So that's the way that the information is being shared and stored in that kind of application. If you if some customer wants to use this on a benchtop, then of course it's also possible to save the information on a local PC or on a USB stick as well. Yep. Then a question from Frank. Frank Vervaken. Will we receive the slides afterwards? Yes.
Sorry? Yeah.
Will we receive the slides afterwards? Yes.
Together with the webinar recording, you will receive the PDF deck as well.
Yeah. And then we have a question from yes, it's difficult for me to pronounce. Yeah, Gaioa or Geoa. Sorry for the bad pronunciation, but how do you save the waveform information, picture or data? The information is saved basically as a comma separated file for the data. So afterwards it can be reproduced in Excel or in other data acquisition programs. Then the next question is from Robert. LabVIEW driver available? Yes, of course. All our instruments come with a LabVIEW driver, so it's also possible to control the unit with LabVIEW. Yeah. And so far, these are all the questions that we have. We will wait another few moments to see if there are any new questions coming into the mailbox. Yes, there is one. That one is from JSIL, and the question is delivery time. To be honest, I have not checked the latest status of the delivery time. Do you have any feeling about that, Daniel?
In 20 seconds, I have a very good feeling.
Okay, yeah. Okay, we will check that for you in a minute.
There is no indication of any delivery delay, which means it's a standard delivery times of 5 weeks.
Okay, good. All right, then I think that we have had all the questions. So.
Yeah, just from the marketing side. So one thing I think that was mentioned when we when Daniel talked about the marketing assets. So all these assets, some of these downloads will be made available when we share the materials about this presentation. But we will, of course, as with other launches in Europe, let you have the detailed launch information with pricing and backgrounds about the instruments, features, and so forth, all in a package that will be deployed this week as well. So this ST5680, all the information, marketing and sales relevant information will be in your mailboxes within this week.
Thank you, Oliver.
There's another question coming in, I think. Let me see. Also from Arne. Can you recall saved data back to the unit? I'm not sure about that. We have to check that. We will give you also a written answer on all the questions. And
one question also to that, is it then for the display purposes that to see the saved data, just to specify, or maybe you can just write to us, and then once we have the background of the question, we can answer to you and send together with the presentation and the recording also our questions and answers.
Yep. Okay, that's I think so far. Yeah. He's mentioning Arne is replying CSF file, but we will look into that and we will come back to you, Arne, with that question. Yeah, with that answer. Yeah.
So thank you very much for the attention, and hopefully the next public webinar will be also successful. Have a nice day, everyone.
Thank you. Bye-bye.
Bye.